In this video here, we're going to take a look at horizontal and vertical components. Now let's suggest that we have a particle which is projected with initial velocity u at an angle alpha above the horizontal. So the angle alpha is what we call the angle of projection. And we get something that looks like this diagram here, right? So we can see the angle of projection here, alpha, and we can see the initial velocity u. Okay. So what we're going to do now then is resolve the velocity into components that act horizontally and vertically. So we get something that looks like this diagram here, right? So hopefully you can see straight away here that we're just going to use basic trigonometry. So applying basic trigonometry, we can see the following here. So cos alpha then is equal to ux over u. And if we rearrange this here then for ux, we get u cos alpha. So this is the initial velocity then in the horizontal sense, so that's equal to u cos alpha. And then for sine alpha here, so sine alpha is equal to uy over u. Again, just rearranging here for uy. So the initial velocity then in the vertical sense here, so uy, is equal to u sine alpha. Okay. So let's just summarize then what we found on the previous page. So when a particle is projected with initial velocity u at an angle alpha above the horizontal component of the initial velocity is u cos alpha. And then finally here, the vertical component of the initial velocity is u sine alpha. So these two components here, the horizontal component and the vertical component, given as u cos alpha and u sine alpha respectively, are really, really important, right? And we'll use this quite extensively throughout this chapter here on projectiles. Okay, so do make a note of these before we continue. Like I said, really, really important. So there we have it. That gives us everything that we need here then for our introduction to horizontal and vertical components. All we're going to do now is take a look at two examples. So starting off with question 1 here, where we're told that a particle is projected from a point on a horizontal plane with an initial velocity of 16 meters per second at an angle of 30 degrees above the horizontal. So for the first part of this question here, part A, it just asks us to find the horizontal and vertical components of the initial velocity. So for part A then, a good starting point here is to draw a diagram. Okay, so we have the horizontal here and we have the initial velocity. Okay, and this angle here then is 30 degrees. Okay. So the initial velocity is 16 meters per second here, like so. What we're going to do now for part A is split this into two components. We'll do it in blue for the horizontal component. So for the horizontal component here, right, we know that ux here, so ux is equal to u cos alpha. We get u cos alpha here. And then for the vertical component then, let's do this in green. So that there is for the vertical component then, which we denote as uy here. That is equal to u sine alpha. Okay. So in that case then, nice and straightforward here. So for ux here, what we get then is u cos alpha. So u here is 16, alpha is 30. So altogether then, we get 16 cos of 30 degrees, like so. So we'll evaluate this in a moment. Let's just denote uy as well. So uy here, that is equal to, again, pretty much identical here, rather than cos though, we have sine. So we get 16 sine of 30 degrees here, like so. So what we need to do now then is evaluate both of these here on our calculator. So if you do this correctly then, what do we get? So for 16 cos of 30 degrees here, we get 13.9 there to one decimal place. So 13.9 meters per second here. And then for 16 sine of 30 degrees here, we get 8 meters per second. Okay. And there we have it. So that gives us the solution there to part A. And then for part B here. So for part B then, nice and straightforward here. It just says express the initial velocity as a vector in the form here of pi plus qj meters per second. So Nice and straightforward then to finish with here for part B. So the initial velocity as a vector here then. So P, this here then is the horizontal component. And for Q here, that is the vertical component. Okay. So what we get then is, I get 13.9 I here, like so. And then we get AJ here, so plus AJ there. Okay, like so. And don't forget here the units, meters per second, like so. And there we have it. So that gives us the solution there to question 1. So moving on to the very last question here, question 2, where we're told that a particle is projected with initial velocity u is equal to 3i plus 4j meters per second. Now for the first part of this question here, part A, it asks us to find the initial speed of the particle. So for part A then, nice and straightforward here. So how do we find the initial speed of the particle? Well, all we simply need to do here then is find the magnitude of the velocity vector. Don't forget that speed is equal to the magnitude of velocity. Okay. So finding the magnitude here of the velocity vector, that would give us then the square root here. So we have the square root of 3 squared plus 4 squared. We get 3 squared plus 4 squared, like so. So nice and straightforward here, right? This is one of our Pythagorean triples. So we get the square root of 25. And the square root of 25 gives us 5 there. Okay. And don't forget the units as well. So 5 meters per second there. Okay. So that gives us the solution to part A there. So now for part B then, it now asks us to find the angle of projection. So for part B then, I would definitely recommend drawing a quick diagram here. It doesn't have to be perfect, right? But just so we can visualize the problem at hand. So we've got the horizontal like that. And we've got the initial velocity as well, right? So I would look, say, something like that. And we've got this angle of projection here. Now, we don't know what this angle is, right? So we're going to call this alpha. Okay, and that's what we're looking to find here for part B. Now, we do know the length here of the horizontal and vertical components, right? So for the horizontal component, that is 3 units. So 3 units there. And then for the vertical component here, that would be 4 units. Okay, like so. And all we're going to do now is just apply some basic trigonometry here. So in that case then, we can see that tan alpha, so tan alpha here is equal to the opposite over the adjacent here. So we get tan alpha is equal to 4 over 3, like so. And if we just want alpha here, right, we just take tan inverse of both sides. So in that case then, alpha is equal to tan inverse. So tan inverse here of 4 over 3, like so. Just put this into your calculator here. And what you should hopefully get then is 53.1 degrees there. Okay. And there we have it. So that gives us the solution there to the very last question, question 2. And that brings us to the end then of this video here on horizontal and vertical components.